so we come back to micro operations, which is what we started this segment with. There are four main types of micro operations: register transfer, arithmetic, logic, and shift. We will be looking at the first three types in today's class, and shift I will continue tomorrow. So as the name suggests, register transfer is basically used to transfer the content of one register to another. Arithmetic for arithmetic operations, math, and logic for comparison operations. So those are the functions they carry out. What exactly are the operations themselves, we'll see now. So these, again, we are just going to be looking at some syntax for register transfer language. This, as we saw, is about transferring the content of register B into register A. This transfer the content of the address portion of DR into register AR. So you have two registers here, AR and DR, and DR contains some data and some address. So you can think of it like your node in your linked list. I assume all of you are doing data structures. So if you take a linked list, you have a data part and an address part. So what this instruction says is you take the address part alone and transfer it to the AR. And the third one is constant to A, so you're taking some constant and putting it in the register A. This one, you put the contents of R1 into ABUS and that of ABUS into R2. So note that first of all that the names of the registers used here, A, B, ABUS, R1, R2, ARMR, they're all arbitrary. You can use X, Y, Z, anything, the only constraint being capital letters like we already saw. So coming back to this instruction, it just says you take R1 and put it in ABUS, and at the same time you put ABUS in R2. So you're shifting two registers. AR generally stands for address register, DR for data register. M of R specifies memory word specified by register R, meaning the content of that register. M is again a shorthand notation of saying M of R. DR to M and M to DR are what we just saw here, the read and write operations respectively. So these are the various register transfer micro operations generally used in a computer. Again, like I said, the set of allowed operations can vary depending on hardware, but these are the most popular ones. The next set of micro operations is arithmetic. This again is quite self-explanatory. I don't think I need to spend much time on this. So R1 plus R2, the contents are added and the result is transferred to R3. Similarly here they are subtracted and the result is sent here. The complement of R2 is taken and put in R2 and so on. So there is nothing much to it. So I guess it's self-explanatory. And your adders, subtractors, all these circuits which you learnt in your digital design course are implemented at the hardware level using these instructions only. So if I have an half adder, say you have x plus y which goes to the sum, then it uses this instruction R1 plus R2 and that goes into R3 and so on. So that's what these few slides tell you. The hardware implementation is based on these register transfer notations or formulae. So with that we have finished arithmetic operations as well.